This is the first video in my series on implementing an LLM from scratch. The way this playlist is structured is that I will be building a transformer-based large language model starting from the very basics, which is version 1 to complex ones from research papers. The first model in this series will be a model that works, but only with the absolute core components any large language model needs to do next token prediction. Now, let me be very clear. The model you and I will be building is very far from the state-of-the-art models like ChatGPT. My goal is for you and I to really understand the skeleton of a transformer-based model. It's not going to be fancy, but it will work. And here are the properties of this first model. So it will be a character level tokenization, meaning the very basic unit of a sentence that the model understands is a character. It will have only one attention layer. It will have only one feed-forward layer. And of course, as I mentioned, the main job is to predict the next character. It will have only one block and one attention head. And then it will have a feed-forward and residual connection. And the model size is just a little above 25,000 parameters. So it is very small. Even though this list looks like a very long one, I can tell you I've stripped away all the bells and whistles. What we have here is the bare minimum needed to generate coherent English text from its training data, not from general English language. Compare this to any current state-of-the-art models, which will have all this plus many more layers, multiple attention heads. It will even have position, encoding, normalization, dropout, scaling trick, and billions or trillions of parameters. As we progress in this course, moving from version 1 to the final version, I will incrementally add these features one by one. The idea is that by the end of this series of playlists, you and I will have enough background knowledge to read through the original transformer paper and actually implement it ourselves. So for every version of this model, I will also be deploying it so that you get hands-on experience with deployments from the very beginning. At the first stage, actually, we'll be deploying on CPU servers, but as the model gets larger, we will move to GPU servers. The link to the deploy version will be found in the pinned comments. I would like to mention, don't worry about the cost of deployment for now, because what we'll be doing can run locally on your machine before we take it to the cloud. And here's a quick demo of the version 1 during inference. Right now, what we have is basically an autocomplete engine. It can only complete text from its training data, which is, by the way, very small piece of text. Let me show you. So it is very small because the model itself is very small. The size of the model, like the number of parameters in the model, determines the amount of data you can train it on. And also right now, the model is terrible at generalization, which is the ability to answer questions that were not explicitly covered during training. This is mainly because the model parameter is very small, as I mentioned earlier. So the model hasn't learned enough to flex. Another important thing is for you to understand the project structure. So the way this is structured is that the full project is a full stack project. It's structured as a full stack project. And why I'm doing this way is because to give viewers the ability to easily explore the final version of what they're about to learn before they start spending their time to do so. I will be teaching only the large language model part of it and not the server and the front-end part. After that, I will expose the model via a fast API endpoint, which can then be accessed with a React.js app. So all you have to do is just clone the full project and then create a folder for each version of the LLM that we'll be doing. And that way you learn what you came for and not how to write fast API code or React.js code. After that, you just have to change the after that, you just have to change the name of the model in the fast API server, and then your model is accessible. So guys, that's it. I hope you learned something and enjoyed the video. Don't forget to subscribe.